Assalamualaikum and a great day to Dr. Fatima and fellow classmates watching. Today my groups and I are presenting the summarization of a research paper we have chosen titled Frontiers in Plasma Proteome Profiling in Platforms. Before that, my groupmates are myself, Muhammad Haris Daniel, and then Muhammad Alif Haikal, Watu Fahmi, and also Nur Amelia. They will introduce themselves at their own parts in this presentation. So for the introduction part, this research focuses on plasma proteomics, a branch of systems biology aimed at identifying protein biomarkers in biofluids for precision medicine. It addresses the challenges of analyzing the plasma proteome, such as high complexity and the wide dynamic range of protein abundance. Next, the objectives. The primary goal is to compare three existing plasma proteomic profiling workflows, which are neat plasma, enriched and also Proteograph XT, to establish a methodology that is sensitive, reproducible, and suitable for large-scale clinical cohorts in biomarker discovery. Moving on to the methodology. The methodology involves several stages. First, human pool plasma samples were divided into aliquots to evaluate three workflows, which are neat plasma, enriched ice, and also Proteograph XT. In neat plasma workflow, samples underwent manual denaturation reduction, alkylation, and overnight protein digestion. Meanwhile, the enriched ice method utilized bead-based protein enrichment followed by a streamlined 3-hour digestion and then a cleanup protocol. The Proteograph XT workflow employed nanoparticle-based protein corona formation with fully automated processing on the S200 instrument, and then all resulting peptides were separated via liquid chromatography and analyzed using dye-based on the timsTOF mass spectrometer with data processing performed using the dye-enhanced search engine. Summarizing the main results, the Proteograph XT workflow exhibited superior performance, identifying over 4.2-fold more protein groups than neat plasma and 2.4-fold more than enriched ice. It also achieved the highest reproducibility with a median coefficient of variation of 10.7%, significantly lower than neat plasma, which is 24.6%, and enriched ice of 21%. Concluding the findings from this research, the study concludes that the Proteograph XT is the superior workflow due to its depth of proteome coverage, quantitative accuracy, and complete automation. These findings establish a robust foundation for identifying low abundance biomarker in large clinical cohorts, large clinical studies, ultimately contributing to the improvement of patient care.
Hello and Assalamualaikum. My name is Nur Amelia and now I'm going to continue about the principles that are applied in these studies. So for the first principle, it is the protein extraction. It is an engineered nanoparticles forming a protein corona with plasma proteins, and it is enriching low abundance proteins. This could allow analysis from just 240 microliter of human plasma membrane. The second one is the protein digestion. Proteins are digested sequentially with lysine and also trypsin. This generates consistent peptides with high sequence coverage. Moving on to the third one is liquid chromatography. Peptides are separated on a C18 reverse phase column using a 65 milligray. This could reduce sample complexity before mass spectrometry. Moving on to the principle 4, which is the tandem mass spectrometry. The timsTOF Proteome diap-based mode combines ion mobility with data independent acquisition. This could improve sensitivity and reproducibility for complex plasma samples. Next, for the protein identification. For protein identification, the study used DIA-NN version 1.8.1 in a library-free workflow. The data are matched against the UniProt Swissport human database with a false discovery rate set at only 1%. This study also enables match between runs to improve identification consistency across samples. Next is the protein quantification. For this protein quantification, the study uses label-free quantification based on peptide precursor ion intensities. This is also performed using DIANN as it allows accurate and reproducible quantification across samples. And the last one is functional and pathway analysis. This is performed using statistical tools in R with visualization done through ggplot2. This research applied functional analysis using cluster profiler and cursors, while pathways are mapped using KGG, wiki pathways, and the human secretome database to understand the biological relevance.
Hi, Assalamualaikum. My name is Proteome. I'm going to continue this presentation on explaining about the benefits. These are the few benefits that we can conclude from our findings. The first one is healthcare improvement, which is early disease detection. By identifying low abundance proteins like cytokines and receptors, the research enables the discovery of biomarkers for early detection of cancer, CVD, and also Alzheimer's. The second one is precision medicine. Deep proteome coverage allows for better classification of diseases, leading to an individualized treatment plans and improved quality of patient care. Now, the second benefit is biomedical research advancement, which is automation for large cohorts. The automated SP100 workflow removes human errors and manual labor, making large-scale clinical studies, which is thousands of samples, feasible and highly reproducible. The second one is secretome or cardiokine discovery. The method identifies a wide array of secreted proteins, which is cardiokines, from cellular compartments like the ER or Golgi, which are valuable for monitoring the organ health. And the last one is pharmaceutical industry, which is in drug target identification. Identification of protein in signaling pathway. For example, TGF-beta, TNF-alpha provides new potential targets for drug development. One of the major concerns under this research is, did the authors consider either conflicting or supporting evidence? The answer is yes. The authors supported their research by citing the well-known limitations of manual neat plasma workflows. For example, dynamic range issues. They also compared their findings to established literature regarding specific biomarkers like TDP43 in neurodegeneration to validate that deep profiling is necessary for clinical relevance. And one shortcoming from this research is that the Proteograph XT workflow is its high sample volume requirement, needing 240 microliter of plasma per sample. In contrast, the neat plasma method requires only 1 microliter. This high volume demand makes the method potentially unsuitable for studies where samples are extremely precious and limited, such as in pediatric research or rare biobank specimens.
Hello, Assalamualaikum. My name is Muhammad Ifaiqah Mazwan. Now I will give a brief explanation about list of databases and bioinformatics tools used in the article. First, UniProt-KB or SwissProt. Basically, a human protein sequence database used for making peptide spectra during the search of their patient profile. Second, data independent aggregation by neural networks. Basically, a search engine utilized for protein identification and quantification through a library-free workflow with MDR enabled. Third, R software and RStudio, the primary environment used for performing statistical analysis and generating data and visualization. Next, ggplot2, basically an R library used to create various graphical representation, including bar plots, protein abundance rankings, and coefficient of variation plots. Another database used in the article is Perseus, basically a statistical software tool from the MaxQuant platform used specifically for generating protein intensity heat maps. Next is KEGG, a database used for pathway enrichment analysis to understand the biological system and functions of the protein. Next, secretome database, basically a source from the Human Protein Atlas. This database was used to access the coverage of soluble secreted proteins across the different workflows. And last but not least, wiki pathways used within the compare cluster function of the cluster profiler package for the detailed pathway enrichment analysis.
Hi everyone, in this tutorial I will show you how to search and explore protein information using UniProt KB, one of the most important protein databases in bioinformatics. UniProt KB has two main parts, which is SwissProt, which contains reviews, high quality entries, and Tremble, which has computationally predicted entries. First, open your web browser and go to www.uniprot.org. So, this is the homepage of UniProt, where we can search for proteins and access annotation. In the search bar at the top, type the name or identifier of protein you want to explore. For example, TP53, which is the gene for a well-known human tumor suppressor protein. And then, press enter or click the search button. After searching, you will see a list of matching entries. For UniProt KB, we usually look for the entries that say SwissProt. These are manually reviewed and most reliable. Click the entry name to open the proteins detail page. Once you're on the page, you will see several useful sections, such as function, names and taxonomy, subcellular location, disease and variants, PTM/processing, expression, interaction, structure, family and domains, sequence and isoform, and similar proteins. That's it for this UniProt tutorial. Practice searching for different proteins to get comfortable with the interface. If you have questions on one and advanced tutorial, let me know.